Be solving quadratics, which we've done throughout this chapter with factoring and the square root method. Today we're going to use the quadratic formula. So with factoring, you were only able to do that with equations that are factorable, and with solving by square roots, you could only do that if you were missing in a middle term, like just the term with x. So the nice thing about solving with the quadratic formula is that you can use it with any equation that's a quadratic. So as long as it has an x squared, you can do it with the quadratic formula. So these are the steps we're going to follow. You should memorize this formula. After you do this and substitute everything in, I'm going to show you how to reduce with the calculator, or at least simplify as much as you can with the calculator. And then you're going to have to simplify radicals like we did earlier in the chapter. So one way to help you remember the quadratic formula is I have a song. It goes to the tune of Pop Goes the Weasel. All right, so it's x equals negative b plus or minus square root b squared minus 4ac all over 2a. Then there's another version of it that is, I think it's the Notre Dame fight song. So it's x equals negative b, add or subtract square root quantity, b squared minus 4ac divided all by 2a. All right, so if you were listening to the audio on this, at least you got a little song for your math notes today. All right, so we're going to be solving with the quadratic formula. The first step is to make sure that it's in standard form, so it means it has to equal 0. So these two already are equal to 0. All right, then we need to label a, b, and c. A is always the value that's in front of the x squared. So a is 1, b is 2, and c is negative 8. Okay, in this problem, a would be 5, b would be 2, and c would be negative 2. All right, so now we're going to substitute into our quadratic formula. So let's do problem number 1. It's x equals, now negative b means make it negative 2 plus or minus, and I'm going to set up some blank parentheses. Just like any time we substitute, put that value in parentheses. So b squared is 2 squared minus 4, because that's part of the formula. Then a is 1 and c is 8. Okay, we'll simplify it later. And then we have 2 times a, which is 1. Okay, so basically when you simplify, we've already substituted into the quadratic formula, but now you have to see, well, what does this actually represent? So you're going to get 3 numbers, one here, here, and here. Negative 2 is just negative 2. 2 times 1, that's 2. So this number, this you can get by doing in your head 2 squared minus 4 times 1 times 8. Or if you're going to use your calculator, I'm leaving off the radical. So all I'm doing is 2 squared minus 4 times 1 times 8. Okay, so that is going to give me, negative 8. We won't get ones with negative values until, I think, tomorrow, or the next day. All right, so now we got 36. Okay, so if you can take the square root of 36, which in this case we can, we get 6. That's nice. We get a whole number. So it's negative 2 plus or minus 6 over 2. If you can't take the square root of it, if it becomes like a decimal, then you have to simplify by pulling out perfect squares. All right, so this plus or minus means that there's 2 options, right? You've had plus or minus in answers before with square roots. So you know this means it could either be negative 2 plus 6, or it could be negative 2 minus 6 over 2. All right, so now let's simplify. Negative 2 plus 6 is 4. 4 divided by 2 is 2. Negative 2 minus 6 is negative 8. When you divide that by 2, you get negative 4. All right, so these are our 2 solutions. All right, problem number 2. This is a, b, and c we've already labeled. So now we're going to do negative b plus or minus b squared minus 4ac. So b squared minus, so we got 2 squared minus 4 times 5 times negative 2 all over 2a. All right, so we have negative 2. 2 times 5 is 10. And then I'm going to put this in my calculator. So 2 squared minus 4 times 5 times negative 2. All right, and I get 44. So this time, when I take the square root of 44, it's not going to turn out to be a whole number. So that means I need to come up with a perfect square. How can I change 44 into two things that multiply to each other? And one of those two numbers is a perfect square. So 4 times 11, which is square root of 4, that's 2 root 11. So I'm going to change this to negative 2 plus or minus 2 root 11 over 10. All right, so I've simplified my radical. I evaluated that. I simplified my radical. And then reduced. The reducing means, since I can't split this up, I can do negative 2 plus 2 root 11 over 10. We know that means two different things. You don't have to split it up this way. All right, but just so you know, plus or minus means you can have one either using the plus, one using the minus, but I actually want to reduce these values. All the values that are not in the radical, they're all divisible by 2, and so therefore I could say negative 1 plus or minus 1 root 11 over 5, negative 1 minus 1 root 11 over 5. Okay, those are my two answers. I would say that you could just leave it as negative 1 plus or minus root 11 over 5. That answer would probably be the best, because that way you don't have to split up as plus and minus. This just says plus. This says minus, but you can just leave it as plus minus. And then you don't need the 1 that's in front of there. All right, when you're done, flip over to the back, and we're going to do a couple more like that. All right, so first thing you need to do is add 27 to both sides. So 2x squared minus 16x plus 27 equals 0. All right, so I'm going to say a is 2, b is negative 16, and c is 27. So it's x equals opposite of b is now plus 16. 2a is 2 times 2, and this part is b squared minus 4ac. So b squared is negative 16, 4a is 2 times 27. All right, so you're going to put all this in your calculator if you need to. So negative 16 squared minus 4 times 2 times 27, and that gives me 40. All right, so take the square root of 40. Well, that doesn't work, so I know that I need to come up with perfect square. So 40 is 4 times 10, so that's really 2 root 10. And again, you're looking at all the numbers, not the 10, so just the 16, 2, and 4. Can they all be divided? They can all be divided by 2. So there's your final reduced answer, 8 plus or minus root 10 all over 2. Okay, this one does not say equals 0, so we're going to move the 18 to the other side. This is a is 3, b is 2, and c is negative 18. So it's x equals negative b plus or minus b squared minus 4ac all over 2a. So it's, let's see, I don't know that one. So we're going to do 2 squared minus 4 times 3 times negative 18. And that gives me 220. And 2 times 3 is 6. All right, so 220, that is not a perfect square. It would be 225, would be the closest perfect square. 220 is divisible by 4, so this is 4 times 55. So this is negative 2 plus or minus 2 root 55 over 6. And then, again, look at the numbers that are not in the radical, and can all those be reduced? We just happen to have a lot of numbers divisible by 2. They're not always going to be divisible by 2, but the last few examples have worked that way. So. And you just leave your answer like that. All right, 2 more problems. These already say equal 0, so we don't need to move anything over. Just let's identify A, B, and C. Here's A, B, and C. Okay, so we're going to do x equals opposite of b is positive 3. 2a is 2 times 1. B squared minus 4 times a times c. So we have negative 3 squared minus 4 times 1 times negative 8. And that's 41. Now, square root of 41, that is not a perfect square. However, there is nothing that goes into 41. Like 41 can't be divisible by 4 or 9 or 16 or 25 or 36. And so that's it. Can't do anything with 41. So you just leave it. Okay, last problem. We already have A, B, and C labeled, so opposite of B plus or minus B squared minus 4AC all over 2A. So we have negative 7 and 2. I'm just going to do what is 7 squared minus 4 times 1. Whoops. 7 squared minus 4 times 1 times 10. That's 9. Alright, so square root of 9 is 3. Negative 7 plus or minus 3 over 2. So if it has a radical in it, you simplify the radical. If it doesn't, it's kind of like problem number 1 that we did over here. You want to split it up. So one answer is negative 7 plus 3 over 2, and another answer is negative 7 minus 3 over 2. If you do this in your calculator, do it as separate with the top and the bottom. So you have negative 4 divided by 2, which is negative 2. Don't put it all in at once. So negative 7 minus 3 divided by 2, so you have negative 10 over 2. That's negative 5. Alright, so if you end up with no radical, you should end up with a whole number or integers or fractions as your answers. Alright, you get bonus points tomorrow if you could sing the quadratic formula song from the video today.